What exactly is a solar panel? Whether it's powering your school calculator or a satellite, the concept behind them is the same. It is first important to get a basic understanding of how light works. Light consists of many discrete particles called photons. These photons have both an electric and magnetic field that oscillate in strength. The energy of a photon determines at what frequency these fields oscillate, and through the formula E equals hf, where h is Planck's constant, the energy of a photon can be found using the light's frequency. The photoelectric effect. As light shines on a metal, these photons interact with the electrons within the metal, transferring their energy. The electron is bound within the metal, but if the energy of the photon is greater than the energy of the forces holding the electron is ejected. The kinetic energy of the electron is equal to the energy of the photon minus the energy binding the electron. One thing to note, however, is that the photons can either transfer all or none of their energy to an electron. This means low-frequency light will never eject electrons, no matter the intensity. Semiconductors. There are a variety of semiconductors, but silicon is one of the most common and is what we will discuss here. The structure of silicon is such that each atom shares its outer electrons with the atoms nearby. This makes them stable and leaves no room for the movement of electrons. By inserting atoms from phosphorus, which has one more electron in the outer shell, or from boron, which has one less, N-type and P-type semiconductors, respectively, can be created. N-type has extra free electrons to carry current, and P-type has fewer, resulting in holes which carry a positive current. To create a solar cell, both a P-type and N-type semiconductor are created. The two are then put together, and a process called diffusion occurs. In this process, the electrons and holes attempt to distribute equally across the now conjoined semiconductors. The free electrons from the N-type move towards the P-type, and the holes from the P-type move towards the N-type. In doing so, positively charged phosphorus is left behind in the N-type semiconductor, and negatively charged boron is left behind in the P-type. The area at which the two semiconductors meet is called the depletion zone. In this zone, an electric field has been created between the positive phosphorus and the negative boron. The field's force opposes the movement of the diffusion. When photons of sufficient energy displace electrons within the depletion zone, the electrons and holes travel separate directions due to the electric field. As the two opposing charges can't rejoin through the depletion zone, they have to move through the provided wire. This is a flow of electrons, or current. The solar cell is now generating power, and this is how solar panels work.